let's talk about y equals the inverse sine of x. So in order to talk about that, first I should talk about the sine of x. So let's say that we have y equals the sine of x, and as you recall, okay, so we took it in between negative pi over 2 and pi over 2, and at negative pi over 2 it equals negative 1, and at positive pi over 2 it's equal to positive 1, and it looks kind of like right? Then when we invert it, reflect it across the line y equals x to get y equals the inverse sine of x, it goes between negative 1 and positive 1. So at negative 1 we have negative pi over 2, and at positive 1 we have positive pi over 2, and it goes kind of like wee. Alright, so let's talk about the domain and range of each of these. The domain of y equals sine of x is between negative pi halves and pi halves. So negative pi over 2 is less than or equal to x is less than or equal to pi over 2. And the range goes from negative 1 to positive 1. Okay, now let's talk about the domain and range of the inverse function. And this is limiting the domain of sine of x so that I can reflect it and get a function, okay? Otherwise, you saw we ended up with a squiggle that went on forever and ever and ever and ever, and it totally failed the vertical line test. So my restricted domain, so the domain of the inverse sine of x goes from, here we plug in negative 1 up to positive 1. Negative 1 is less than or equal to x is less than or equal to 1. And we get out negative pi halves up to positive pi halves. Negative pi over 2 is less than or equal to y is less than or equal to pi over 2. All right. Now that we've got that groundwork done, let's take the derivative. So y equals the inverse sine of x, and we can take the derivative of both sides. No, we don't know how to take the derivative of the inverse sine of x, so let's do the sine of both sides. As long as we do the same thing to both sides, we're okay. Okay, the sine of y is the sine of y, whatever that may be. The sine of the inverse sine, inverse functions cancel each other out, so we'd have just plain old x. Alrighty, then we can take the derivative of both of these. So we're going to take the derivative in terms of x of the sine of y, and we're going to take the derivative in terms of x of x. Alrighty, well, the derivative of the sine is the cosine. And then the derivative of the inside, well, the derivative of y is just dy dx or y prime, whichever notation you prefer. The derivative of x in terms of x is 1. To isolate the derivative of y, I take y prime divided by the cosine of y, and I do the same thing to both sides. So y prime equals 1 over the cosine of y. And yes, this does equal the secant of y, but I'm going to go a different direction than this using some trig foo. So, time for trig foo. First thing to think about is, what if this equals 0? Oh no, right? Our paper could burst into flames. Okay, well, way back up here, all the million years ago, we just said that y is in between negative pi over 2 and positive pi over 2. Okay? Because we looked at our function, we said, oh yeah. Okay, so y is in between negative pi over 2 and positive pi over 2. Now let's pretend y is theta, because I don't want to mix myself up with x's and y's at this moment. So I'm going to consider theta. And I'm going to say that theta is in between negative pi over half, pi over 2, and positive pi over 2. Okay, so I'm going to look at my unit circle, and I'm thinking about theta, so don't worry about x's and y's right now, because it'll mess you the heck up. Okay, if my angle is in between negative pi halves, here's negative pi halves, up to positive pi halves, pi over 2, that's this chunk of the unit circle. Now, let's think about cosine. Forget y for a minute. I just want the cosine of theta. Cosine of theta is the x value on the unit circle. So looking at the x value on the unit circle, it is always positive. The only exceptions are here and here where it's 0. So here and here it's a problem. So I better go back and restrict this function even more. I'm going to go back and say, okay, as long as we say y is strictly between pi over 2, negative pi over 2, and positive pi over 2, we're okay. So I'm going to restrict this even more and say that then it is never going to be 0. In fact, here it is always positive, okay? So the cosine of y then here is always positive. So between negative pi over 2 and pi over 2, cos y is positive. Okay, cool. Then I say, oh great, but this is still in terms of y. So I'm pleased and delighted to hear that it's legal to do that, but I don't actually know what the cosine of y is. That is a problem. So let's do a little bit more trig foo. So ka to a. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent, we don't need this one, is the opposite over the adjacent. And I'm going to draw a triangle and think about this. So this is some right triangle. And over here, this angle is going to be angle y, right? Because we're thinking about the cosine of some angle. All right. I know way back up here, I said the sine y is equal to x. Sine y is equal to x. So the sine is the opposite over the hypotenuse, the opposite over the hypotenuse. And it has to equal x. So I'm going to call this x and this 1. It could be a different ratio. This could be 2x, and then this would be 2. But they would have to be proportional to each other, and this side would also have to be proportional to the two other sides. So I'm just going to call it x and 1. I can use the Pythagorean Theorem to find this other side. So let's see. I'm going to call this question mark because I'm getting enough variables in here. I'm getting confused, so I'm just going to use question mark. So x squared plus question mark squared equals 1 squared. That means that x squared plus question mark squared equals 1. I'm going to take away x squared from both sides. So question mark squared equals 1 minus x squared. And I'm going to take the square root of both sides. So question mark equals plus or minus the square root of 1 minus x squared. All right, so the cosine of y equals plus or minus the square root of 1 minus x squared, there's that side, over 1. Oh, but wait, I just said that cos y is positive on the interval we're interested in, so I don't even need this plus or minus nonsense. I can say that cos y equals, and divided by 1, well, that's just the number. So cosine of y equals positive square root of 1 minus x squared. So back up here, I get to say, I don't really care about the secant of y because that's not very informative, but I can say that the derivative equals 1 over cos y, and cos y equals the square root of 1 minus x squared. That only works on this interval that we restricted our function to in order to take the inverse. There we have it. That is how we get the inverse of this exciting function.